Good morning, everyone. I hope you all are doing well. So let's start our new lesson for today. Module 1.1, Rational and Irrational Numbers. Now, what are these numbers? We know numbers of like 1, 2, 3, infinity. But what are these rational and irrational numbers? So let's find it out. We have all these numbers. We all know we have integers, we have decimals, we have fractions, we have 0, 2, 1, 2, 3, infinity, we have pi. So we have all these numbers, but all these numbers can be grouped into rational and irrational numbers. For example, the first group of numbers are called natural numbers. What are natural numbers? The numbers which can be counted on your fingers, and it starts from 1 to infinity. Then we have whole numbers. Whole numbers are also like natural numbers, but it includes 0. So natural numbers are from 1 to infinity, which does not include 0. And whole numbers are numbers which include 0 to infinity. Then we have integers. Integers are the numbers that can be called as positive numbers, which is on the right side of 0, and negative numbers, which is on the left side of 0. So these numbers are called integers. They have special sign like positive or negative. So we have natural numbers, whole numbers, integers. Then comes the rational numbers. Now what are the rational numbers? The numbers which includes natural numbers, whole numbers with the 0, integers with the negative and positive, and also the fractions and decimals. So all these numbers are called rational numbers. Rational numbers include fractions, repeating decimals. Repeating means the decimal which repeats after the point. It goes on repeating the same number. Terminating decimals. Terminating means after the decimal the number stops. It does not repeat. For example, 0.5 or 0.12. So we have natural numbers, whole numbers, integers, and rational numbers. What are these all groups called? The real number system. So these all are called the real numbers. Rational numbers, if we take the root word of rational, it is called as ratio. And ratio means fractions. Any number that can be written as the quotient, a fraction of two integers is a rational numbers. For example, negative 5, 0.25. We have negative 5, 0.25, mixed number 2, 1 over 3, 0.333, the repeating numbers or the repeating decimals. These numbers are called the rational numbers. For example, you have 0.25. Now tell me, is it a repeating decimal or a terminating decimal? For sure, it is a terminating decimal because it stops after the decimal. After the decimal, there are only 2 digits and then it stops. It doesn't repeat. For example, I have a fraction 1 over 4. When I'll divide it, I'll get the answer 0.25, which is also called as a quarter. Negative 1 and negative 4 is the same as 1 over 4. Or if I just multiply it with 2, I'll get 2 over 8. Like I'm getting the number increased. And then if I divide this, I will again get the answer 0.25, which is a terminating decimal. Or if I multiply it with 4, I'll get negative 4 and negative 16. Now again if I divide, I'll get the answer 0.25. So it is called a terminating decimal, can be written as a quotient of only 2 integers. So terminating decimals are rational integer. It can be written as positive or a negative. So it is called a rational number. Now 0.3333, so what is happening over here? It is repeating. So the decimals, after the decimal, the numbers are repeating. So it is called a repeating decimal. It can be written as 1 over 3 or negative 1 over negative 3. If I multiply it with 3, I'll get 3 over 9. Or if I multiply it with negative 3, I'll get negative 3 over negative 9. A repeating decimal can be written as a quotient of two integers. Again, we can write it as positive integers or negative integers. So it is a repeating decimal, and it is also called a rational number. Rational numbers are, it can be fractions with both simple and mixed number, decimals with both repeating or terminating decimals, integers with negatives and positive numbers. So all these things are called rational numbers. Now how can we change decimals to fractions and fractions to decimals? So here we are converting fractions into decimals. Now I have a fraction called 3 over 8. I can change this and write it as 3 divided by 8. So let's divide it 8 with 3. Now we know that 3, the dividend is smaller than the divisor. So we'll put a decimal and bring one more 0. Now it's 30. So 8 times 0 will give you 3. But if I join this 2, it will be as 30, which is 8 times 3 will give you 24. 24 is closer to 30. Similarly, we will keep on dividing and dividing until we get a remainder. So we got a remainder 0 and the quotient as 0.375. We got the answer. So what did happen? We changed the fraction into decimal. So now the decimal, after the decimal, the number 375 has stopped. Is it repeating? Are we getting more again 375, 375, 375? No. So it is called a terminating decimal. To change a fraction to a decimal, take the top divided by the bottom or numerator divided by the denominator. Now change the fractions into decimals or decimal to fraction. How can we change decimal to fraction? The decimal is 0.03. Now after decimal, how many digits you have? 2. 2 digits means having 2 zeros, which is 100. So I'll write 300, or we can write 03 over 100. Similarly, 0.35 can be written as 35 over 100, or if we reduce it, we'll get 7 over 20. This decimal can also be written as a mixed number. 6 will take it as a whole number and 0.7. So 7 is having only one digit. One digit means 10, having 1 0. Similarly, we are going to do this one as well. Repeating decimals. Now we have fraction 1 over 3, which is also called as 1 divided by 3. Let's divide them the same way. Now, what is happening? We did not get a final remainder and the question has kept on repeating and repeating and repeating. So 0.3333 can be also written as 0.3 with a dash on the head of 3. Why? Because 3 is getting repeated. Or shall we take 2 3's and put a dash up? No. Every rational number or fraction either terminates or repeats when written as a decimal. So it can be as a terminating or a repeating, but here it is called as a repeating. And what number is repeating? 3. So we'll write only once with a dash on the head. Similarly, I have the number 45 repeating. 45 is getting repeated. So how are we going to write it? We'll write 454? No. 4 and 54 is getting repeated? No. We'll write it as 45 and a dash on the head of 45 means the whole 45 is getting repeated. 45, 45, 45 and so on. One more example I'll give you. The number 8 and then 3, 3, 3, 3, 3. That means only 3 is getting repeated, not the 8. So we'll write it as 83 getting repeated, no. Or 33 getting repeated, no. 8 and only 3 is getting repeated. So we'll put a dash on 3. So this is how we write the repeating decimals. Instead of writing the whole with the dot, 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 we'll just write what number is getting repeated with a dash on the head. Now, how to square a number? What do you mean by square a number? To square a number, just multiply it by itself. For example, I want the square of 3, means I'm going to multiply 3 with 3. I'm going to multiply 3 times 3, which is 9. So square of 3 means 9. That means the number we need to multiply it with itself. Squared is often written as a little 2 like this. A little 2. So it says that the square of 4 is 16. Means 4 we are multiplying it by itself to get 16. This 2, the small 2, is called a squared. This says that 4 squared equals to 16. The little 2 says the number appears twice in multiplying. Now what about negative numbers when we multiply the negative squares? You can also square the negative numbers. Example, here we have a number as negative 5. How can we square them? How can we multiply 2 times? So negative 5 will multiply it with negative 5. What is the rule for multiplying negative signs? It will change into a positive sign. So we'll get it as 25. Because a negative times a negative gives a positive. Why? When you square a negative number, you get a positive result. Just the same as if you had a squared positive number. For example, negative 5 will give you positive 25. It's the same way as you are multiplying it a positive times. So we can say that the square of positive and the square of negative numbers are always same or always positive. Now what is a square root? A square root of a number is a value that can be multiplied by itself to give the original number. For example, we know that the square of 3 is 9. What about the square root of 9 is 3? So it's just the opposite. Square root is opposite of square. 3 squares will give you 9. So the 9 square root will be 3. 3 squared is 9, so the square root of 9 is 3. It's just the opposite of each other. And the symbol for the square root is like this. We call it as a radical. This is the special symbol that means square root. It is a sort of like a tick and actually started hundreds of years ago as a dot with a flick upwards. It is also called the radical and always makes math look important. You can use it like this. So it says that the square root of 9 is 3. You would say square root of 9 equals to 3. Similarly, what is the square root of 25? So we know that 5 times 5 or 5 squared is 25. So the opposite will be, the square root of 25 will be 5. Now we have some perfect squares. The perfect squares are the squares of the whole numbers. For example, the square of 1, that means 1 times 1 is 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16, etc. So these are the perfect squares and these are the answers. Similarly, we are going to talk about the cubes and the cube roots. A number is a perfect square if you multiply the same number, such as 1 times 1. This is the perfect square, right? And the opposite is the square root. Similarly, so this is the perfect square we know. Now, we are going to learn about perfect cube. Perfect cube is the same but multiplied it 3 times. The same number by itself but 3 times. Cube here refers to 3. For example, same like how we find the volume with length, width and height, same like that we are going to find the cube of a number by multiplying itself 3 times. So square we multiply 2 times by itself, cube will multiply 3 times by itself. So the cube root of 3, the cube of 3 will be 3 times 3 times 3, which is 3 times 3, 9, 9 times 3, 27. So here are the examples. 3 cube, and the cube is represented with a small 3 on the number. So 3 cube is 27. So what will be the cube root of 27? 3. So it's just the opposite, cube and cube root. Similarly, how we did square and square root is the same as cube and cube root. Cube of 6 means 6 times 6 times 6 is 216. So what is the cube root of 216? 6. Similarly, 4 over 5 cube means 4 times 4 times 4, 64. 5 times 5 times 5, 125. So what is the cube root of the fraction? It's the same as 4 over 5. Now, sometimes what happens is we don't find a perfect square or we don't find a perfect cube. So how to find a non-perfect square? For example, can you find the square root of 27? Now, as discussed earlier, we have some perfect squares over here. Tell me, where is number 27, the square root of 27 on this number scale? It's in between 25 and 36. So we'll move on to this slide. So what is the square root of 27? It comes in between 25 and 36. So what is the square root of 25? 5. And what is the square root of 36? 6. So the square root of 27 will be in between 5 and 6. Similarly, for example, if we have 11, 11 is a non-perfect square. Why? Because 11 lies in between 9 and 16. And 9 is the square root of 3 and 16 is the square root of 4. So 11, the square root of 11 will be in between 3 and 4. So this is how we find the non-perfect squares. Here are some examples of the non-perfect squares, like square root of 55 will be in between square root of 49 and 64. What is the square root of 49? 7, and square root of 64 is 8. Similarly, we are going to find out for all these non-perfect squares. And what are these non-perfect squares are called, which is not the perfect? They are called irrational numbers. It does not behave like the other subsets. So irrational numbers includes a pi, a non-repeating or non-terminating decimals, like this one. It's not even repeating and it's not even the same. For example, 2 1 then 2 1 1 then 2 1 1 1 2 1 1 1 1. Can you see? Is it the same? Is it repeating in the same term? No. Neither it is stopping. So these kind of decimals are called irrational numbers. And also the non-perfect squares are called irrational numbers. So, we studied about the natural numbers, whole numbers, integers, and rational numbers. So, these are the group which comes in the same form. What about the ones which is not having a perfect square, a non-terminating or non-repeating decimals? They are called irrational numbers, and together they call as real number system, because irrational numbers do not fit in these groups. So it is the other side. So it's called rational numbers, irrational numbers, and together they call it as real number system. Thank you.